Hello students, this is my next lecture on dynamics, lecture 17. In this lecture I am going to discuss tangential and normal velocities. The velocities of a particle along and perpendicular to the tangent at a point of the path are called the tangential and the normal velocities. Let AB be the intrinsic curve. Intrinsic curve means whose equation is in the form of S and psi. So the equation is S is equal to F psi AB be the intrinsic curve whose equation is S is equal to F psi, on which P, S psi and Q coordinates S plus delta S, psi plus delta psi be any two position of a moving particle at time t and t plus delta t respectively. Draw tangents T1P and T2Q at P and Q respectively. Draw QM perpendicular on T1P produced. T1P produced. Draw a perpendicular line QM and join PQ. Okay. Then the arc length AP is small s and the angle PT1 T2 is psi. The arc length AQ is equal to S plus delta S and the angle Q T2, and let this be X, OX, OY axis. So angle Q T2X is psi plus delta psi. So if we take this point as R, this point, then this angle is equal to delta psi, as exterior angle psi plus delta psi is equal to this angle psi and addition of this angle. So this must be equal to delta psi. So you will get the figure like this. So clearly the arc AP is equal to S, the arc AQ is equal to S plus delta S. Therefore arc PQ is equal to S plus delta S minus S, that is delta S. Angle PT1, not S, it is X. X, not S. PT1 X is equal to psi and Q T2 X is equal to psi plus delta psi. Therefore, if we take this point as R, then angle T1 R T2, this angle must be equal to delta psi. Choose chord PQ equal to delta C. Then if the limiting condition is applied as Q tends to P, then the chord PQ tends to arc PQ, that is delta C tends to delta S. Therefore delta C by delta S is equal to 1. Therefore, the tangential velocity at P is equal to rate of change of displacement along the tangent at time t plus delta t minus rate of change of displacement along the tangent at time t. That is limit delta t tends to 0 Pm divided by delta t. Now, in triangle QPM, this triangle. In triangle QPM, cos angle QPM, this angle is equal to PM divided by PQ. So from here we can write as PM is equal, PM is equal to PQ into cos angle QPM. Now PQ is equal to delta C. So it is delta C cos angle QPM divided by delta T. Now this can be adjusted like delta C by delta S into delta S by delta T cos angle QPM. This implies limit delta T tends to 0, delta S by delta T cos QPM, as we have already discussed. Delta C by delta S tends to 1. So, and if Q tends to P, then angle QPM tends to 0 and cos 0 is equal to 1. So, we are left with limit delta T tends to 0, delta S by delta T, or ds by dt, or s dot. So, the tangential velocity is s dot. Now come to the normal velocity. So normal velocity at P means rate of change of displacement perpendicular to the tangent at P. This should be rate of change of displacement perpendicular to the tangent at P. So what is this? This must be equal to perpendicular to the tangent, change is equal to QM. So this equal to limit delta T tends to 0, QM by delta T. Again in triangle QPM, if we find sine angle QPM, so we will get QM divided by PQ. So QM is replaced by PQ sine angle QPM. So this is QM replaced by PQ sine angle QPM divided by delta T. Again PQ is delta C. So we can adjust like delta C by delta S into delta S by delta T sine angle QPM. Now delta C by delta S tends to 1. So this becomes 1. And as Q tends to P, angle QPM tends to 0. So sine angle QPM tends to 0. So we are left with 0. So normal velocity at P is equal to 0. Thank you. In the next class, we will discuss tangential and normal acceleration.